Hello and welcome again. It is December 21st, 2025. The sky above us is dark, the winter solstice has arrived, and deep in the constellation Leo, roughly 170 million miles from where you are sitting right now, a visitor is leaving. We are talking, of course, about 3I Atlas, also known as C2025N1. Just 2 days ago, this interstellar object made its closest approach to Earth, a silent, high-velocity flyby that had astronomers across the globe glued to their telemetry screens. Now, the data is coming in, and the object is already receding into the outer solar system at a staggering speed of nearly 130,000 miles per hour. It is a ghost in the machine of our solar system, a transient blip that has already begun its long goodbye. But as it fades from view, the story it is telling us is only just beginning to unravel. Today, we are going to look past the headlines and the initial excitement to understand exactly what just happened, and more importantly, what we missed. If you want to stay ahead of these deep space discoveries as we analyze the data in real time, make sure you subscribe to the channel. We are tracking this object until it vanishes completely, and you won't want to miss the updates coming in the next few weeks. Let's look closer at the data. The trajectory of 3I Atlas has been described by the Space Reporting Center as clean, stable, and unchanged. To the casual observer, that sounds reassuring. It implies a simple rock, obeying the simple laws of gravity, swinging by the sun and heading back out. But clean in astrophysics often masks complex. We are looking at an object that formed around another star billions of years ago, ejected by some cataclysmic event or gravitational slingshot, drifting through the void for eons before stumbling upon our yellow dwarf star. It didn't stop. It didn't slow down. It pierced the plane of our solar system, skirted the edge of our habitable zone, and is now rushing towards the orbit of Jupiter. The sheer kinetic energy involved here is difficult to visualize. But imagine a mountain moving at a fraction of the speed of light's lower bounds, indifferent to the gravitational wells that usually trap comets and asteroids. However, the most compelling piece of data emerging in the last 48 hours isn't about where it is going, but how it is behaving as it leaves. Observers are reporting a phenomenon that has been informally dubbed the heartbeat shift. This is not a radio signal, let's be very clear about that early on, but a subtle, rhythmic fluctuation in brightness. As of today, December 21st, amateur astronomers and major observatories alike are seeing the object blink faintly against the background stars. The leading theory is residual heating. The object passed closer to the sun weeks before it reached us, and that solar encounter likely baked the surface, triggering sublimation of ices we are only just beginning to identify. As it rotates, different facets of this heated surface present themselves to Earth, creating a lighthouse effect. But the periodicity of this blinking is where the mystery deepens. We are seeing a pulse that suggests a complex rotation, something that isn't just a simple tumble. It's a wobble, a precession that hints at an uneven distribution of mass. If this were a standard comet, we would expect a chaotic spin, especially after the thermal shock of perihelion. Instead, we are seeing something that looks almost regulated. Not artificial, necessarily, but structurally peculiar. The heartbeat is steady, persistent, and it is complicating the picture of a simple chunk of ice. It implies internal structure. It implies that the center of mass is not where the visual center of the object appears to be. This connects to the broader question of what 3I Atlas actually is. We have had interstellar visitors before, Oumuamua in 2017, Borisov in 2019. Each one broke the mold. Oumuamua was a sliver, a shard that accelerated without a visible tail. Borisov was a ghost, dissolving into dust. 3I Atlas is different again. It is robust. It survived the solar passage intact. It is not breaking up. The heartbeat tells us it is solid, coherent, and dense enough to hold its shape against the tidal forces it just experienced. And yet, despite this solidity, it is behaving like a comet in other ways. We are detecting the sublimation of ices, the shedding of dust. But the heartbeat rhythm doesn't quite match the rate of material ejection. Usually, when a comet vents gas, the jets act like thrusters, spinning the object up or down. We call this the Yorp effect or simple outgassing torque. But 3I Atlas seems to be maintaining this specific brightness fluctuation frequency despite the visible activity in its coma. It is as if the spin is decoupled from the thrust of the gas. That is a detail that keeps orbital dynamicists awake at night. It suggests that the object has a tremendous angular momentum, a heavy, dense core that isn't easily pushed around by surface jets. As we watch it fade into the constellation Leo, we have to ask, what is driving this heartbeat? Is it shape? Is it albedo? Patches of bright ice and dark organic tholins flashing as they spin? Or is it something more fundamental about the object's geometry? The light curve data we are pulling down from the telescopes in Chile and Hawaii is showing a jaggedness that contradicts a smooth, spherical body. It is elongated, perhaps flattened, or maybe even bilobed like Arrokoth. But unlike Arrokoth, which sits frozen in the Kuiper belt, this thing is hot, active, and moving at escape velocity. The heartbeat is our clock. It is the metronome by which we are measuring the final days of this encounter. Every pulse of light is a data point, a frame in a movie that is ending too quickly. We are racing to correlate this blinking with the spectroscopic readings, trying to see if the chemical composition changes in sync with the rotation. Does the heartbeat coincide with a blast of hydroxyl? Does it line up with the X-ray emissions? We are looking for patterns in the noise, trying to find the signal that tells us how this machine, this natural cosmic machine, works. This brings us to the edge of what we know today. The object is 170 million miles away, a pinprick of light in a vast darkness. But that pinprick is pulsing. It is alive with physics, with chemistry, with the history of a star system that died or ejected it billions of years ago. We are watching the heartbeat of a ghost. And as we will see in the next chapter, this heartbeat is not the only thing spinning out of control in the data. There is a conflict emerging in the rotation numbers, a discrepancy between what the amateurs are seeing and what the models predict. That suggests we might be looking at something far more dynamic than a simple tumbling rock. The stability of the trajectory masks a chaotic violence on the surface, a paradox of motion that we need to unravel. As we established in the previous report, 3I Atlas is leaving us, pulsing with a rhythmic heartbeat of light that hints at a complex, elongated shape. But as we dig deeper into the telemetry, that heartbeat is starting to look less like a steady rhythm and more like a symptom of a much deeper paradox. We are facing a conflict in the data, a divergence between two sets of observations that, on the surface, simply should not coexist. This is where the story shifts from a simple flyby to a puzzle of orbital mechanics that is baffling the experts. Let's look closer at the data coming from the amateur astronomy community. In the age of network telescopes and advanced image processing, amateur is a misnomer. These are dedicated analysts with serious hardware, and they are reporting something startling. By tracking the tightly collimated jets of gas and dust streaming from the object's nucleus, they have clocked a rotation rate that is incredibly fast. They are seeing these jets whip around at up to 30 degrees per minute. Do the math, and that implies a full rotation of the object every 12 minutes. For a body of this size, estimated to be several hundred meters across, spinning that fast is pushing the limits of structural integrity. It's a centrifuge. Any loose material, any gravel or dust on the surface, should be flung off into space instantly. It suggests a monolithic, solid object, held together by significant tensile strength, not a rubble pile comet, like we often see in our own system. But here is the crucial detail that throws a wrench into the gears. While the jet suggests this frantic, dizzying spin, the object's tail tells a completely different story. 3I Atlas displays a prominent anti-tail, a spike of dust that appears to point toward the Sun, a geometric illusion caused by Earth crossing the object's orbital plane. This anti-tail is behaving with eerie precision. It rotates, yes, but not at 30 degrees per minute. It rotates at a steady, languid rate of roughly 30 to 35 degrees per day. This contradicts what we previously thought about cometary dynamics. How can a single object exhibit two radically different rotation rates simultaneously? If the nucleus is spinning every 12 minutes, the features attached to it, the sources of the jets, should be spinning with it. The tail, which is just material flowing away from those sources, should reflect that chaos. Instead, we have a nucleus that appears to be pirouetting wildly, while its shadow, its wake, moves with the slow, deliberate grace of a clock hand. The anti-tail's movement matches orbital geometry models with near-perfect precision, a predictability that reassures conventional explanations, even as it hints at hidden complexity beneath the surface. So, what does this actually mean? We are left with a few uncomfortable possibilities. One is that our interpretation of the jets is wrong. Perhaps what looks like rotation is actually a spiraling outflow, a lawn sprinkler effect, where the gas is twisting as it leaves a slowly rotating body. That would save the standard model. It would mean the object is spinning slowly, matching the anti-tail, and the rapid motion is just turbulence in the coma. But the heartbeat brightness shifts we discussed earlier are fast too. They align more closely with the rapid spin hypothesis. This brings us to a more exotic possibility, one that has been whispered in the corridors of the Space Reporting Center, but rarely spoken aloud on the record. Could the object be stabilized? Some have suggested exotic explanations, ranging from unusual internal structure to gyroscopic stabilization. Imagine a core that spins independently of its shell, or a mass distribution so extreme that it creates a stable axis of rotation despite the external torques. In engineering terms, we call this a dual-spin spacecraft, a spinning section for stability and a despun platform for instruments. In nature, we don't see that. Nature tends to lock things together. Friction, gravity, and tidal forces usually synchronize rotation over billions of years. For an ancient interstellar object to maintain such a complex dynamic state suggests either a freakish coincidence of physics or a structure we simply don't understand. I want to pause here and hear from you. What do you think is happening? Is this a data error, a natural anomaly we haven't seen before, or something else? Drop a comment below with your theory. Are we looking at a lawn sprinkler comet or a gyroscope in the dark? The mystery deepens when you consider the implications of the technological rotation mechanism's speculation. While most scientists dismiss this as science fiction, the mere fact that the data allows for such an interpretation is telling. We are looking at a behavior that challenges simple comet models, particularly for an object already moving away from the Sun. Usually, comets calm down as they retreat. They cool off. Their jets subside. Their spin stabilizes. 3I Atlas is doing the opposite. It is maintaining this high-energy state even as the solar input fades. It is acting like an engine that hasn't quite shut down yet. The disconnect between the 12-minute spin and the 35-degree per day alignment is the spin paradox. It is the defining mystery of this encounter. If the object is natural, we are missing a chapter in our textbook on cometary physics. We are seeing a new class of object, perhaps a shard of a planetary core, stripped of its mantle, spinning rapidly from the violence of its birth, yet dragging a heavy veil of dust that obeys the slow laws of orbital mechanics. But if we step back, there is another layer to this. The stability of the anti-tail, that slow 30-35 degree per day shift, points to something else: mass, a lot of it. To maintain that kind of stable orientation against the pressure of the solar wind and the thrust of its own jets, 3I Atlas must be heavy, much heavier than a ball of ice. This connects to the heartbeat. The density required to hold together under rapid spin also supports the idea of a metallic or rocky composition. We aren't looking at a fluffy snowball. We are looking at a bullet. As we try to reconcile these spinning jets with the stable tail, we have to look at what the object is actually made of. If the motion is confusing, perhaps the chemistry can provide the answer. Is it rock? Is it metal? Or is it something that shouldn't be there at all? In the next chapter, we are going to analyze the spectrum. We are going to look at the impossible chemistry of 3I Atlas, the hydroxyl lines, the X-ray emissions that extend for 250,000 miles, and the isotopic ratios that prove, without a shadow of a doubt, that this thing is not from around here. The spin is a puzzle, but the fingerprint it leaves in the light might just be the key. Building on the paradox of the object's rotation, we now turn our instruments to the light itself. In astronomy, light is touch. By breaking down the spectrum of the light reflecting off 3I Atlas and the light emitted by its coma, we can taste the atmosphere of this visitor. We can determine what it is made of, molecule by molecule. And what we are finding is a chemical fingerprint that is simultaneously reassuringly familiar and deeply alien. This is where the debate between natural object and artificial probe faces its hardest test, the cold, hard facts of spectroscopy. Let's look closer at the data from the radio telescopes. As 3I Atlas heated up during its solar approach, it began to vent. Radio observations have detected strong emission lines of hydroxyl, OH. For the chemists watching, this is the smoking gun of water ice. When water, H2O, sublimates from a comet's surface and gets hit by solar UV radiation, it breaks down into hydrogen and hydroxyl. Seeing OH is standard procedure for a comet. It tells us there is ice there, melting in the sun. This is the primary evidence that Harvard astrophysicist Avi Loeb and others cite when they describe the object as most likely natural. It behaves like a dirty snowball. It has volatiles. It reacts to heat. If this were a spaceship, it would be a spaceship wrapped in a thick shell of ancient ice, venting water like a steam engine. But the story doesn't end with water. The Chandra X-ray Observatory has been staring at the object, and it has picked up something impressive. X-ray emissions extending nearly 250,000 miles from the nucleus. That is a cloud of high-energy interaction larger than the distance from the Earth to the Moon. These emissions are caused by charge exchange, solar wind ions slamming into neutral gases in the comet's coma, and stealing electrons. Again, this is a known natural process. We've seen it with comets like Ison and Hyakutake. It confirms that 3I Atlas has a substantial atmosphere, a thick cloud of gas surrounding it. It strongly supports unnatural origin. It looks, for all intents and purposes, like a comet. However, here is the crucial detail that keeps the analyst up at night. While the types of gases are familiar, the ratios are wrong. Major observatories tracking the receding tail are reporting unfamiliar isotopic ratios. Isotopes are versions of elements with different numbers of neutrons, carbon-12 versus carbon-13, deuterium versus hydrogen. In our solar system, these ratios are fairly standard, a signature of the cloud of gas and dust that formed the Sun and planets 4.6 billion years ago. But 3I Atlas is different. Its ratios are skewed. It is rich in dust and gas that preserves chemical signatures from another planetary system formed long before Earth existed. We are looking at the ashes of a different fire. This connects to the time capsule theory. NASA and ESI characterize it as a cosmic time capsule rather than a spacecraft, and the isotopic data backs this up. We are sampling a soup of ingredients cooked up in a different part of the galaxy, perhaps billions of years ago. It might contain complex organic molecules, the building blocks of life, synthesized under a different star. The unfamiliar isotopic ratios are the stamp of its passport. They prove it is truly interstellar. It is not a stray rock from the Oort cloud. It is a visitor from the deep. So, what does this actually mean for the artificial hypothesis? It makes it much harder to sustain. If you were building a probe, why wrap it in water ice? Why make it vent hydroxyl? Why give it a coma that generates X-rays via solar wind interaction? It seems like an awful lot of camouflage. The principle of Occam's razor suggests the simplest explanation is usually the right one. It looks like a comet. It smells like a comet, literally, if you count the trace ammonia and methane. So, it is a comet. And yet the speculation persists. Why? Because of the combination of factors. We have a comet that spins every 12 minutes without flying apart, implying high-density strength, maintains a stable anti-tail, implying high mass stabilization, and possesses a trajectory that is suspiciously clean. The chemistry says nature, but the physics says anomaly. Could it be both? Could it be a natural object that has been modified? Or, and this is the realm of pure speculation, could the ice be shielding? A way to protect a long-duration traveler from cosmic rays and micrometeoroids. We have to be careful here. Science demands evidence, not wishful thinking. The chemical signatures are the strongest evidence we have, and they point away from technology. They point to a natural, albeit exotic, origin. But even if it is a rock that has traveled light years to get here. It carries the frozen history of a dead world. As we watch the spectral lines fade, we are left with a picture of an object that is chemically consistent with a natural body, but dynamically puzzling. It is a paradox wrapped in ice. But there is one more test it had to pass to be considered truly intelligent, and that was the test of intent. Did it look at us? Did it change course? Did it signal? The chemistry is silent on this, but the trajectory is not. In the next chapter, we will look at the path 3I Atlas took, its upcoming rendezvous with Jupiter, and the deafening silence that accompanied its flyby. We will explore why, if this were a probe, it showed absolutely no interest in the only habitable planet in the neighborhood. We have looked at the spin, and we have looked at the chemistry. We have seen the paradox of a rapid rotation paired with a stable tail, and we have tasted the ancient alien ice sublimating into the void. But if 3I Atlas were artificial, if there were even a ghost of a chance that this was a probe, one detail now seems unavoidable. It showed no particular interest in Earth. This is the cold shower for the first contact enthusiasts. The trajectory of this object is the final, and perhaps most damning, piece of evidence against the idea of a visitor who wants to say hello. Let's look closer at the data regarding its path. The Space Reporting Center confirms that the trajectory is clean, stable, and unchanged. This is critical. A powered craft, or even a probe using a solar sail, would likely make course corrections. It would adjust its vector to maximize observation time or to enter a parking orbit. 3I Atlas did none of that. It fell into the solar system, accelerated around the sun, and is now falling out. It followed the invisible rails of gravity with absolute obedience. It passed closer to the sun weeks before its flyby of our planet, a maneuver that makes sense for a gravity assist, but less sense for a surveillance mission focused on Earth. It treated us as a waypoint, not a destination. Here is the crucial detail. During its closest approach, when it was just 170 million miles away, a stone's throw in cosmic terms, it remained silent. We listened. The Deep Space Network, the Green Bank Telescope, the arrays in the Atacama, everyone was listening. We looked for narrow-band radio signals, laser pulses, structured transmissions. We found nothing. No wow signal, no prime numbers, just the hiss of the solar wind and the thermal noise of the comet itself. It never slowed, never emitted any directed or structured signals, remaining confined to a path near the ecliptic plane shaped by gravity rather than intent. So, what does this actually mean? It means that if 3I Atlas is a probe, it is a probe that doesn't care about us. It suggests a mission profile that is entirely passive. If it gathered data, it did so silently and briefly, and whatever that mission might have been, it is already complete. It swept through the system, collected its photons or its dust samples, and moved on. This indifference is almost more unsettling than hostility. It implies we are not significant enough to warrant a brake maneuver. We are just scenery. But the journey isn't over. The object's future trajectory points not toward Earth, but toward Jupiter. In March 2026, 3I Atlas will pass near the giant planet's Hill sphere, the region where Jupiter's gravity dominates satellites. This is a fascinating orbital coincidence. Jupiter is the vacuum cleaner of the solar system, the gravity well that catches or flings comets. For an interstellar object to thread the needle and pass near Jupiter on its way out is statistically interesting. It will get a final gravitational kick, a boost that will hurl it even faster toward the edge of the system. By April 2029, it is expected to cross Pluto's orbit. After that, it disappears forever into interstellar space. It will cross the heliopause, the boundary where the solar wind gives way to the interstellar medium, and return to the dark from which it came. It leaves behind no sign that it ever noticed us at all. This trajectory, Sun, Earth, Jupiter, out, is a classic scattering orbit. It is exactly what you would expect from a random rock falling from the galactic plane. It doesn't require a pilot. It doesn't require an AI. It just requires Newton's laws. And yet, the precision of it, the way it skimmed the ecliptic, the way it aligned with the major bodies, keeps the what if alive. What if the mission wasn't to contact us, but to map the system? What if the heartbeat was a scanning LiDAR? What if the silence was operational security? These are questions we cannot answer with data, only with imagination. The data says rock. The data says gravity. The data says goodbye. But as we watch it head for Jupiter, we are reminded of the sheer scale of the cosmos. We are a small blue dot, and 3I Atlas is a traveler that has seen more stars than we can count. Its priorities lie elsewhere. This connects to the final verdict. We have the spin, the chemistry, and the path. We have the experts weighing in, from Harvard to ESA. In the final chapter, we will bring all these threads together. We will look at the consensus view, the lingering doubts, and the legacy of this encounter. We will ask the ultimate question. If this was a natural event, why does it feel so much like a missed connection? And if something truly comes for us one day, how will we know the difference? We have tracked 3I Atlas from its closest approach to its silent departure. We have analyzed the heartbeat of its light curve, the paradox of its rapid spin versus its stable tail, the chemical fingerprint of its ancient ice, and the gravitational arc that is carrying it past Jupiter and into the dark. Now, as the object fades into the constellation Leo, it is time to draw a conclusion. What was it, and what does its visit mean for us? The scientific consensus has solidified, but it is a consensus built on a foundation of anomalies. Harvard astrophysicist Avi Loeb, a man who once famously speculated that the interstellar object Oumuamua could be an artificial light sail, has stepped back in this case. Citing the clear chemical signatures, the hydroxyl, the carbon-based dust, and the total absence of engineered signals, he describes 3I Atlas as most likely natural. This is a significant shift. When the leading voice for the alien probe hypothesis says it's a rock, the world tends to listen. NASA and the European Space Agency echo this view, characterizing the object as a cosmic time capsule rather than a spacecraft. They see it as a pristine fragment from a distant star system, a frozen record of a galaxy we can never visit. But natural does not mean boring. In fact, the natural explanation is in some ways more profound. If 3I Atlas is a natural object, it is a survivor of impossible odds. It was ejected from its home system, survived the radiation of interstellar space for eons, and just happened to thread the needle of our solar system. The fact that it exists at all is a miracle of statistics. And yet, the object continues to surprise. The prominent anti-tail, pointed toward the Sun, rotates at a steady rate of roughly 30-35 degrees per day, matching orbital geometry models with near-perfect precision. This predictability reassures conventional explanations even as it hints at hidden complexity beneath the surface. It reminds us that nature is capable of order that looks like engineering. The heartbeat shift, likely caused by residual heating, is the pulse of a dying world, not a living machine. So, what does this actually mean for our place in the universe? It means we are part of a busy highway. If interstellar wanderers are common, most will pass unnoticed. We only saw 3I Atlas because our technology has improved. How many have we missed? How many silent, dark ships, natural or otherwise, have cruised through our system while we were looking the other way? The encounter with 3I Atlas leaves us with an unsettling possibility. Not that we were visited, but that we were simply passed by. The object showed no interest in us. It didn't slow down. It didn't signal. It treated Earth, with all its radio noise and city lights, as just another rock in the void. It is a humbling reminder of the scale of the cosmos. We are not the center of the story. We are just bystanders, watching the traffic go by. If one day something truly comes for us, it will not look like this. It will not be ancient, silent, precise, and already gone. It will stop. It will speak. 3I Atlas was not that messenger. It was a ghost, a piece of cosmic drift that brushed against our lives for a few weeks and then vanished. As it crosses Pluto's orbit in April 2029, it will be just another cold object in the Kuiper Belt, indistinguishable from the billions of frozen rocks that live there. But it will carry with it the memory of our Sun. It will carry the slight gravitational tug of Jupiter, and it will carry the gaze of our telescopes, the data we stripped from it, the questions we asked of it. We have learned that the galaxy is full of material. We have learned that the chemistry of life, water, carbon, organics, is not unique to us. It is out there, frozen in the dark, waiting for a star to wake it up. 3I Atlas was a messenger after all. It didn't bring a greeting, but it brought a confirmation. We are not alone in the chemistry of the universe, even if we are alone in the silence. If you enjoyed this deep dive into the mystery of 3I Atlas, please leave a like on the video. It helps us continue to bring you this kind of detailed, scientific analysis. And keep looking up. The next visitor might already be on its way.